So in looking at part 2 of the respiratory system, we're going to begin by looking at Dalton's law. And Dalton's law states that each gas in a mixture of gases exerts its own pressure as if no other gases were present. So if we think about atmospheric air, and we've said previously that at sea level, the atmosphere is made of a combination of gases and atmospheric pressure is at 760 millimeter mercury. That means to arrive at this 760, each one of those gases has its own partial pressure as if no other gas were present. And if we wanted to denote what partial pressure was, we would have that capital P as we see in the first bullet point, and the X means the gas that we're trying to find the partial pressure of. So if you're talking about the partial pressure of oxygen, that means just the pressure of oxygen in the atmosphere minus all of the other gases. You would have capital P with an O2. If you wanted to find the partial pressure of argon gas, you'd have capital P with an AR. So all of those gases together will add up to 760 at atmospheric pressure. And just like we know in pulmonary ventilation, gases move from a high to low area of pressure, each gas can move independently of the other gases from an area where it is in a high pressure to an area of where it is in a low pressure. And this is very important because we'll see later that oxygen and carbon dioxide can move in opposite directions down their partial pressure gradient. So this is very important in respiration. So we see here all of the gases that make up the atmospheric pressure. These are averages. They may be slightly different, particularly things like water when the humidity of the air is different. But oxygen, roughly about 20.9% of atmospheric air at sea level. Nitrogen, 78.6%. So we see that nitrogen makes up a large majority of the gas in the atmospheric air, but we'll see that nitrogen does not dissolve very well in blood plasma, so we don't hear about nitrogen as much as it's in much about its effects. Argon, 0.093%, water, 3%, and carbon dioxide, 0.04%. You need to know how to convert the percentage of a gas in the atmosphere to its partial pressure. To do that, you would simply convert the percent to a decimal and multiply it by the entire pressure of the atmosphere, which is 760. So for instance, if we wanted to find the partial pressure of oxygen in the atmosphere, we convert its percentage in the atmosphere to a decimal. So its percentage is 20.9. Moving the decimal to the left 2 places, we would have 0.209, and we multiply that times 760. So we would see that the partial pressure of oxygen in atmospheric air is 158.84 millimeter mercury. And if you did that with all of the gases and added them up at sea level, they should equal out to 760.